All right, today we are diving headfirst into a grand cosmic detective story. We're on the hunt for the fundamental clues that explain, well, everything. Our entire reality, from the tiniest flicker of light to the biggest galaxy you can imagine.
I mean, really think about that for a second. It's a question people have been asking for forever. If you could just keep zooming in, way past molecules, past atoms, past everything you learned in high school chemistry class, what would you actually find at the very bottom? What are the absolute, indivisible Legos that build you, me, and this entire universe?
Well, it turns out the answer is hidden in a world you can literally never see. To get to the bottom of it, we have to become detectives. We have to investigate a crime scene that's smaller than anything we can possibly fathom. And that, right there, is the world of particle physics.
Okay, so every good detective story needs a lineup of suspects, right? In our case, these are the fundamental particles. This is the cast of characters that makes up all the matter in the entire universe.
And you know what? At its core, it's actually pretty simple. We've got two main families here. First up, you've got the quarks. Think of these guys as the ultimate Lego bricks. They're really social particles that always clump together to build bigger things. And then we have the leptons, like the good old electron. These are the lightweights, kind of the solo artists of the particle world.
And here's a perfect example of how those Lego bricks snap together. A proton, the very heart of an atom, isn't fundamental at all. It actually has a recipe. You just take two up quarks, one down quark, stick them together, and boom, you've built one of the absolute pillars of our universe. It's really that elegant.
All right, so we've met our suspects, but just knowing the characters isn't going to cut it. We need to understand the rules they play by. What makes them attract each other, or push apart, or even fall apart. That's where the four fundamental forces come in. This is the cosmic rulebook. So this is basically the rulebook for everything. You have the strong force, which is like this cosmic superglue holding the center of an atom together against just incredible forces trying to rip it apart. Then there's electromagnetism. That governs basically everything you can see and touch. The weak force is the one behind stuff like radioactive decay. And then, believe it or not, you have gravity. It's actually the weakest of them all, but it's the one that bosses around galaxies over huge cosmic distances. So we had the players, our particles, and we had the rules, the forces. And together, they built this incredible theory we call the Standard Model. But for decades, there was this one huge, gaping hole in the story. The theory was beautiful, it worked, except it had no way to explain why particles have mass in the first place. A crucial suspect was missing from the lineup. Just look at this timeline. We found the electron, then the nucleus, then the neutron, one discovery after another. And then way back in 1964, a theory pops up proposing a brand new particle, the Higgs boson, that could finally solve this mystery of mass. But for almost 50 years, it was just a ghost. A theory with zero proof. A massive question mark was just hanging over all of physics. Until this year, 2012, down at the Large Hadron Collider at CERN, after decades of searching, sifting through data from trillions upon trillions of collisions, physicists finally found it. The final piece of the puzzle finally clicked into place. So what is this thing? Well, the Higgs boson is the physical proof of an invisible energy field that fills the entire universe. We call it the Higgs field. Here's the best way to think about it. Imagine this field is like a crowded room at a party. A really famous person walks in and immediately gets mobbed, and they have to move really slowly through the crowd. That resistance, that difficulty moving, that's like having a lot of mass. Now, someone less well-known walks in, and they only attract a few people, so they move through more easily, less mass. And a particle like a photon, it's like someone nobody knows. It just zips right through without interacting at all. That's zero mass. That stickiness is mass. So how in the world do you even find something like that? Well, the detective work is pretty explosive. Inside these giant machines like the Large Hadron Collider, you take particles, you accelerate them to just shy of the speed of light, and then you smash them into each other. And it's in the tiny, fleeting aftermath of that collision that brand new, undiscovered particles can pop into existence just long enough for your detectors to see them.
Okay, I know what you're probably thinking. Giant particle colliders, invisible fields, smashing protons. What does any of this have to do with my life, right? Well, as it turns out, this high-level detective work has completely changed your world in ways you use every single day.
Take the World Wide Web, for example. You think it was made so we could watch cat videos? Nope. It was actually invented at CERN by physicists who just needed a better way to instantly share huge amounts of data with their colleagues all across the globe. Or how about MRI scanners in hospitals? They run on these incredibly powerful superconducting magnets, the exact same technology that was perfected to build particle accelerators that bend and focus those beams of protons. It really boils down to this fantastic quote from Edward Teller: "The science of today is the technology of tomorrow." The simple act of chasing pure knowledge, of trying to answer these huge fundamental questions, it just has a habit of spinning off the technologies that end up defining our future. But just like in any great mystery, there's always a final twist. Just when we think we've cracked the case of what matter is, we stumble upon a shocking new clue. It turns out that the matter we've been talking about this whole time, the stuff that makes up you, me, the planets, the stars, it's barely anything at all. The biggest cases are still wide open. I mean, just look at this. This is absolutely mind-blowing. Everything we have just discussed, the quarks, the leptons, the Higgs boson, our entire beautiful standard model, all of it describes a mere 5% of the known universe. Let that sink in. 95% of our reality is made of dark matter and dark energy, mysterious things that we only know are there because we can see their gravitational pull on everything else. What they are is one of the greatest unsolved mysteries in all of science. So, yeah, the cosmic detective story is nowhere near finished. We've gone from thinking the atom was the end of the line to discovering this whole zoo of particles and forces. And now we know we can only even see a tiny fraction of what's really out there. Which leaves us with the ultimate cliffhanger, doesn't it? What completely new, earth-shattering understanding of our reality is waiting for us just beyond the next big discovery?